So welcome back to Desmos. Yeah, starting with Desmos for this 4.7 section, dealing eventually with the quadratic formula. But before we dive into the equation and all that, I think it's helpful to just see the visual of what we'll need or what we should go from. So this whole chapter has all been about these suckers, these bad boys, these parabolas that act like this. Sometimes they go down, sometimes they open upwards. Sometimes they shift to the left or to the right. Sometimes they go low. Sometimes they go up a little bit lower or higher. And so what we've been doing with the past few sections, solving them, is pretty much saying, hey, well, what are these points right here? These solutions right here that hit the x-axis. And so what's nice is that this section, in comparison to factoring, in comparison to completing the square, these two equations right here, believe it or not, two equations, these equations help us solve for these types of solutions that we come across. And again, this is without factoring, without completing the square. And if you're not convinced, well, let's see just exactly how it looks. So no matter what parabola we're using, let's say that we plot this first one. Let's change this up so it looks a little bit nicer and easy to spot. Let's make this a little bit thicker. No matter what, this blue line is going to tell us where the solution is. One of them. But think about this. We have two of them. So we just have one. Well, that's not two. Even if we look very, very closely, we'll see that the point that these two lines intersect at are on the x-axis. So it's definitely a solution there. If we go and we activate the second version of this, we see that we have a second line that's cutting through. So notice that as the graph shifts to whatever parabola we want, the line will intersect with it no matter what because of a few reasons. And a lot of it comes down to the coefficients. I'll make sure that this link gets posted on Schoology if you want to check it out more. So back to the actual math stuff. So the quadratic formula is a formula that helps us piece together solutions no matter what. If you want to read through this first page, go for it, but it's pretty much building the idea that there's another way to solve a quadratic that's not completing the square or factoring. It's an interesting breakdown also of how it's done. It's pretty much coming down to moving the constant to the right-hand side, completing the square with any coefficients that's there, and then solving for the x terms. So I think it's kind of cool if you want to look into that. But what we're looking at here is pretty much just how it's used. So what we need for this, if we're going to solve using the quadratic formula, which again, as you saw, is this. If you want to think of this like the ice cream jingle, this is a long equation, a long formula to memorize, but think of it like this. And I'll even get the resolution up so we can see it a little bit better. So think of this as, and my Algebra 2 students know this from a few years ago still, so that's awesome. X equals negative b plus or minus square root b squared minus 4ac all over 2a. It sounds crazy. It makes me think of ice cream, but ice cream's great, and that makes it stick for me. So what this does, again, will give us solutions, but it depends on how we use our coefficients. And this really comes down to if all terms are on the same side. And if they're not, then we have to reevaluate it. But if they're nice, they'll give us a problem where all the terms are on the same side already. But for this first one, what would we have to move across to get to the same sides? Like all the terms on the same side. Hopefully you're saying this 2 would have to move over. So leaving us 5x squared minus 2x equals negative 2. And so from here, we have to denote what our a coefficient is. Or sorry, it's not even equal to. This is now equal to 0, so good. So our a coefficient's 5. Our b coefficient is negative 2. Funny enough, our c constant is negative 2. And I'll do my best to color coordinate on this. So the b term seen here in blue. In black, I'll underline our constant of c. And so now using the equation that we have here, we plug in for everywhere that we see a variable, we plug in one of these numbers. So we take negative b, so negative, negative 2. We use plus or minus because as we saw from the Desmos, there are two solutions, or sometimes just one. That happens also. We have b squared, so this is going to be negative 2 being squared. Subtracting 4, multiplying with a, which is 5, multiplying with c, which is negative 2. So that's the first part up top. In the denominator, we have 2 times a, so 2 times 5. All good so far. So now it's up to you to really think strategically on your order of operations. So we have negative b, so the opposite of a negative 2 would just be positive 2. We have plus or minus. If we simplify inside parentheses, negative 2 squared is just 4. We're then subtracting the product of 4, 5, and negative 2. So this would be negative 40. And in addition to that, our denominator is 10. We can simplify our radical further because we have 2 still on the outside. Now the square root of 44, where this is all over 10, and this is all equal to x. Keep in mind we're solving for solutions, so we want x equals the whole time. The way that we can break this fraction down is a little odd from what we've done previously, but root 44 we can break down because we know that in there 4 and 11 are factors. And again, we'll separate this into two fractions now. So now keeping this separate, we'll rewrite 2 over 10 as just 1/5. We could also acknowledge that root 4 is here, so we could rewrite this again as 1/5 plus or minus 2 root 11 over 10. And to really seal the deal, notice a lot of this problem is just simplifying radicals or simplifying the fraction. So to simplify this further, 2 over 10, we can just rewrite that as root 11 over 5. So our two answers in this case for this problem would be 1 plus root 11 over 5 or 1 deducting root 11 over 5. And of course x equals, because so we want to know that we're talking about a solution. I'll give you a moment for the next one. So pause it, give this next problem a shot. We'll come back on this in a moment. So we need to move all of our terms to the other side, so we should have x squared plus 4x plus 4 equals 0. Our a term is going to be 1, b term is 4, c term is 4. If we take negative b, so negative 4, plus or minus the square root of b squared, so 16, minus 4 times 1 times c, so 4 is here. Notice I have this memorized and I move pretty quickly, so if you need to pause the video at any point in time, please do so. This is all over 2a, so remember, all over 2. We can rewrite this since we have 16 and we're deducting the product of 4, 1, and 4. In our radical, we have nothing. So this is negative 4 plus or minus 0. This is all over 2. So believe it or not, since this is adding but also subtracting 0, our only answer here is negative 4 over 2, which we can just simplify to negative 2, which is our only solution. Notice that. So in this case, we did not have two solutions. We'll see in the next video that occasionally this happens, where we might have one solution or no solution. But all of the work here makes sense. If you get stuck along the way, please pause, look back, look over what we did. Also come into class with questions if you feel as if you have them still.